Kia ora Year 12, this is question 2E from last year's integration paper. If you're looking for question 1E, I've already done that one and it's on the external exam video playlist. So this is a kinematics question and it goes like this. We're given the acceleration of an object by this function, blah blah, the usual stuff, and then we've got the object was moving with a velocity of 12 meters per second when t equals 4, and our job is to find the velocity after 10 seconds. So working through quickly what we're going to have to do, we're told that when t equals 4, v equals 12. In other words, v of 4 is equal to 12. And we have to find v after 10 seconds. So what we need to do is take that acceleration function and anti-differentiate to get velocity. So we don't have to separate the variables, just anti-differentiate this. 20 log t over t dt. So let's look a little bit more closely at how we can split that up. We can think of it as 20 times 1 over t times the log of t dt. Now that really helps us because this 1 over t is the derivative of log t. So that suggests that this is just going to be the power rule as follows. So we'll have 20 times the log of t squared. Now look at that and think about what happens when we differentiate this. We end up with 2 log of t times 1 over t, which is just about what I want here. Sorry, here, but I don't want the 2. So I divide through by it. So that's what we get, plus c. And that gives me an expression for velocity, which is 10 times the log of t squared plus c. And that's the hardest part of the question done. Now we have to substitute in the values that we know. So at t equals 4, velocity equals 12. So 12 equals 10 times the log of 4 squared plus c, giving me c equals 12 minus 10 log 4 squared. Right, now what does that give us? As a decimal, that gives me negative 7.128. And the velocity function is now finished, so it's 10 times the log of t squared minus 7.218. And the very last thing to do is to chuck t equals 10 in there and work it out. And let's see what we get. That gives us 45.8, and we need to have units, so it's meters per second. Thanks for watching. I'll do question 3E soon.